Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Insert greatest common divisors in linked list. Leetcode 2807. In this problem, we are given the head of the linked list with head pointer in which each node contains an integer value. Then we should insert a new node between every pair of adjacent nodes with a value equal to the greatest common divisor of them. And then we should return the linked list after the insertion. The greatest common divisor of two numbers is largest positive integer that evenly divides both the numbers. Then in example 1, we are given following list, and this is the answer list. So GCD of 18 and 6 is 6. So we insert 6 between 18 and 6. Now GCD of 6 and 10 is 2. So we insert 2 between 6 and 10. And finally GCD of 10 and 3 is 1 because they don't have any common factors. So we insert 1 between 10 and 3. And now that there are no more adjacent nodes remaining, we will return the linked list. Then in example 2, we have a linked list with only one node. So there are no pairs of adjacent nodes, and that's why we will return the initial input list. Now in terms of solution, the problem involves two things. One is bit of math where we need to calculate the GCD between two nodes, and second is pointer manipulation between two adjacent nodes in the linked list. Now let's discuss the Euclidean algorithm for calculating the GCD. Also, I want to mention that I will cover this algorithm in detail in a separate video. In this video, I will just cover how it works and how we can use it in our problem. The Euclidean algorithm is an efficient method for computing the GCD of two integers. The GCD of two integers is the largest positive integer that evenly divides both the numbers without leaving a remainder. So now in this algorithm, we take two integers a and b, a being the larger number and b being the smaller, and we divide the larger number by the smaller number. Then we set the smaller number equal to the remainder and the larger number equal to the smaller number. And we will repeat this process until the remainder becomes 0. And the GCD is a last non-zero remainder. For example, if a is equal to 18 and b is equal to 6, then we will get b is equal to a modulo b. So b becomes 0 and a will be equal to b, that is 6. And since the remainder is 0, we will return GCD equal to 6. Similarly, if a is equal to 10 and b is equal to 6, then 10 modulo 6 is 4. So we will replace a by b and b by remainder. So a will be equal to 6 and b will be equal to 4. So now our new a and b will be 6 and 4. So we again do 6 modulo 4, that will give us 2. And we again replace a by b and b by remainders. So a will be equal to 4 and b will be equal to 2. And now a modulo b is equal to 0. So we set b is equal to remainder, that is 0. But before that we set a is equal to b, that is 2. And now since b or remainder is equal to 0, we will return 2 as the GCD between 10 and 6. Similarly, if we take a equal to 10 and b equal to 3, then we will make a equal to b, that is 3, and b will be equal to a modulo b, that is 10 modulo 3 equal to 1. And now we again make a equal to 1 and b is equal to 3 modulo 1, that is 0. And now since remainder is equal to 0, we will return GCD between 10 and 3 as 1. And now that we have covered how we can calculate the GCD, let's see how we can insert the GCD value in the linked list. And for that, we can start iterating on the linked list, starting from head pointer, and let's call it current as always. Then we have to insert the value between current and current.next pointer. And because we need two adjacent nodes, we will run the loop until current and current.next are not null. So we will actually calculate the GCD value between current node's value and the next node's value. So GCD of 18 and 6 is 6. So we will create a new GCD node and update the pointer. So what we will do is we will set current.next is equal to this GCD node and GCD.next is equal to next pointer, and move the current pointer to next to process the next pair. So similarly, again, this will be the next pointer after the current. So again, we calculate the GCD between 6 and 10. That will be 2. So we will again create a new node, set current.next equal to this new GCD node and GCD.next equal to next, and move current to next. So again, current value will be 10 and next node's value is 3. So the GCD between 10 and 3 is 1. So we will create a new node and insert it, and again set current.next equal to GCD node and GCD node.next as next, and move current to next. And finally, we see that current value is there, but current.next is not there. So we will stop our loop because there are no two adjacent nodes remaining now for us to calculate the GCD. So that will be our ending condition. And finally, we will return this updated linked list as our answer. Now let's jump into the code part. So first we will check if we have at least two elements in the linked list. Because to calculate GCD, we need at least two numbers. If not, then we can return the input list itself. So now we will start iterating on the linked list using the current pointer. And while current is not equal to null and current.next is not equal to null, that means we have two adjacent elements for which we can calculate the GCD. So let's take the next node for that. So now let's calculate the GCD between two adjacent nodes, that is current and current.next. And the GCD value will be GCD of current.value and next.value. We will define the GCD function shortly, and then we can just create a new node with GCD value, and now we have to insert it. So we set GCD's next pointer to current.next, and current.next pointer is updated to new GCD node. And now we have inserted the node in the linked list. We will move our current to next for the next iteration, and finally we'll return the head pointer. And now let's define our GCD function. We take two integers a and b and return the factor between them. And while b is not equal to 0, we will continue our loop. So we swap the value between a and b by setting a equal to b and b equal to a modulo b. And finally we will return the last remainder as our answer. Now let's run this code. Cool. Let's submit this code. Awesome. In terms of time complexity, it will be O of n, where n is the number of elements in a linked list. And the reason is the current pointer goes through each node only once. And same is true for the next pointer as well. And then we calculate the GCD. And the upper bound for it will be O of b, where b is less than a, because we are replacing b by a modulo b, and a modulo b will be smaller than b. So for example, if a is equal to 18 and b is equal to 5, then we will replace b by a modulo b, that will be 3, which is less than 5, and so on. In reality, and we will try to prove it in the upcoming video, the time complexity of Euclid algorithm is O of log minimum of a and b. For this problem, either we can assume it as m or constant. And if we assume it as constant, given a and b are 32-bit integers, then the time complexity will be O of n. Otherwise, the time complexity is O of n into m, where n is the number of elements in the linked list and m is the average time it takes to calculate GCD between two numbers. And then we add n minus 1 elements, so that again takes O of n time. So overall, the time complexity says O of n or O of n into m, depending on how you look at it. And in terms of space complexity, it will be O of n, because we are adding n minus 1 new elements to the linked list. So I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. If you have any questions or suggestions, write them in the comment box. Thank you for watching. Have a nice time.